Hey everyone, so today I'm going to show you how to use a real database in your Springboot project. For the example, I'm going to use once again this person API that I made a couple of videos before. Um, I'm going to share as well the repo link in the video description. And for this video, I'm not going to install from scratch a database engine. I'm going to use Docker, and I'm going to use as well the Beaver database management tool to be able to access to the database and see the data and so on. There is other database management systems over there, but this is a pretty good one and is free, so you can download it from dbeaver.io. And you have versions for Windows, for Linux, for Mac. I'm going to use Docker as well. In this video I'm not going to cover the installation of Docker, but it's pretty easy, so you can go to the official Docker page and click on the get started and follow the steps. It's easy to install, so no problems over there. If you are not familiar with Docker, it's okay. I'm going to show you a few concepts and commands to run everything, and then you can research, let's say, a little bit more. So let's get started with this. I'm going to run the API over here. It's a simple person API with a REST with few REST endpoints. So let me show you one here in the Postman. Let's do a find all, which is an HTTP GET request to the API slash v1 slash persons. This is going to return everything that we have in our table for persons, and this is a pageable endpoint, so we can specify how many items we want in the page, which page do we want, and if we want to sort by any criteria. So basically, or currently, this API is using H2, which is a in-memory database, and this is not good for a real application. I mean, a production application because this H2 database is for testing proposals. So in order to start using a real database engine, we are going to use Docker because it's an amazing tool to create containers and run your application inside of that container in a isolated way, so the other application will not interfere in your wherever your application is. And this is an amazing tool that allows you to run the same application in any cloud, any computer, any host, wherever, without changes. So we have here a cool site, which is the Docker Hub, where you can find another image, which is a concept that Docker used. Image is basically a blueprint or the instructions that Docker needs in order to create a container. Basically, it will tell you need this and this and this and this and that in order to create that. So for instance, I'm going to use MariaDB as my database engine. So I'm going to choose this. Once you check the repository in the Docker Hub for the application that you want, basically you are going to find cool documentation about what this image does and how to run it. So let's just copy and paste this command, which is the basic command to run an image for Docker. let's jump to our project and let's create a new file to put there the command. Let's put something like build and run db.sh, and this is going to be a bash script. Let's copy and paste, and let's just put this to be more easy to read this command. Alright, so we have here the docker run command, which is telling to the docker to run that we are going to run a new container. We can specify a name over here. Let's put something like Springboot. We can specify some configuration for that container. We can see in the documentation right over here what kind of property we can use. For instance, we can change the root password, the database, we can create a new username. So let's start with the database, and just let's follow the syntax, the -e MySQL database, and let's create a database called persons. Another argument will be the user, because I don't want to share the root user. Let's put just Springboot or Spring, and then the MySQL password right over here. We need to specify as well the port where this application is going to run, and that is with the -p. By default the port is 3306, so this is the port for your host machine, and this is the port for the container. We have like a mapping over here. If you want to change this in your host, you're able to do that. So let's remove the D, because that is going to send the command to the background, and we want to see the logs as well. For last, this is the image name, and we can specify a version if we want, but we are going to just remove that and just download the latest image. So this is pretty much all that we need. So let's run this script. This is going to create a new container with all our information that we need, the username with the table, this username, password, and whatever. So there we go, it's finished. So let's go to the beaver, and let's create a new connection to see if we are able to connect. Let's choose the MariaDB, which is our engine. Let's write here our data basically is running in the local machine, so let's write just persons, and the username is Spring, the password is Spring, and let's try the connection. So if you are doing this for the first time with the beaver, maybe you will need the MariaDB driver, and it's going to prompt a new window to download the driver. I already have the driver, so maybe that could be different in your case. So let's click finish. So we have here our DB for persons. We have we don't have any table yet, but let's do some modification in our application in order to connect to our database. So the first thing that we need is we are not going to use h2 anymore, so let's put here MariaDB, And the syntax is we need to specify the username, the password, and the host. So let me just copy and paste this over here to do this quickly. Let's replace all this. So basically we have the host, the port, and the database name. And this syntax is telling that if you don't find any db host variable, just use localhost. The same for the port, and for the database name we must specify a database name. The same for the username and for the password. So this is the first step. The second step is that we will need the database driver, and we need to specify that in our POM XML file. So we can find the driver in the Maven repository. Just let's write something like MariaDB client, and we will find it. We can just copy and paste this dependency. We can remove the version because Spring is going to handle that for us, and we can just comment this or delete because we are not going to use more h2. Let's re-import the POM file, and I think that is all that we need. So let's restart our application and see what happened. So basically we have our container running the MariaDB. Alright, we need to specify the as well the username and password. Here we have an error for the reader. What is wrong here? Oh, this blank space. So we don't specify any username and password, so this will fail. Let's see the error. So here it's going to try to connect to the DB username, so let's specify that. So probably you don't want to put here the username and password because it will be easy to read for everyone. So one thing that you could do is go here to the running configuration and use the environment variables. So let's create our variables. Let's create the DB name, which is persons. Let's create another one, which is DB username with value Spring, and another one which is DB password with the value Spring. Okay, and let's run everything again. So as I said earlier, we have the database engine running in the container. We update our driver here in the POM file. We add the MariaDB client, and we use the application.yml to specify that our data source is not an h2 anymore, it's a MariaDB, and we specify the host, the port, the database name table, database, and the username and the password. So the application is up. So let's go once again to the dbeaver. Let's refresh the database, and now we have two tables. That is because we specify to JPA to be able to update our scripts for the creation. So you are going to see um, over here, then here we have the creation of the table that we need to start working with the API, which is the person table and the sequence person. So if I restart this, obviously it's not going to delete everything and try to create a new one. It's just to keep the one that already exists. If we take a look to the person table, we don't have any data because it's a new database. So if I try to hit the REST endpoint, it's going to show me the same thing. It's empty. So let's start to write some data using our API. So I'm going to use a post method over here. So I create the first entity. Let's see the database again. Let's refresh this. We have our first entity. Let's write a few more. We had 3 then now. So same last name, same name but different ID. Let's try to run some updates, changing the last name for the person with ID 1. Let's refresh this. We have the update successfully. Let's do in the other way around. Let's modify from the database. Let's write here from db, and let's save this, and let's run the final method again. We can see here is actually working just fine. Let's try the delete. Let's delete the ID 3. So let's try this again. As you can see, it's running. So basically we have everything in place. Probably you will need few commands here to stop and run again the database. For instance, we have here our Docker container running. If we try to stop this, it's not going to stop. So basically, for instance, the command that you will need to stop is Docker container stop, and you can specify the name of your container, which is Springboot Maria DB. So this is going to stop the container. You can see here it's dispatching the shutdown signal. So our application is not going to be able to communicate to the database. You can try that if you want by doing a new HTTP request. You are going to see an exception or a timeout, and if you want to run again your container, this script is not going to help you, because this script is just for the creation of the container. So your container is already in place, so you can use Docker container run and specify once again the name of your container. Let me see what is wrong here. Springboot Maria DB. Let me just in case copy this. Maybe it's start not run. There we go. And this is going to run in the background, so you can go with Docker PS to see if actually it's running. So let's go back to our Postman. We have the exception here, but probably if we go to our application console, we are going to be able to connect once again to our database, and of course our data is there because the container is alive. So there you go, my friends. This was how to run, how to integrate a real database to your Springboot project. Hopes that this helped, and see you.